Imagine a time before time. There was no space, no matter, only an unimaginable point of energy. Then, in a fraction of a second, everything changed. The Big Bang erupted, flinging forth a fiery maelstrom of particles and energy. This event, roughly 13.8 billion years ago, marked the birth of our universe. The universe, initially a searing inferno, began to cool. As it did, energy transformed into particles, forming the building blocks of matter. Gravity, a fundamental force, drew these particles together, creating the first stars and galaxies. These celestial pioneers illuminated the darkness, their light stretching across the expanding cosmos. Our own solar system, a mere blip on the cosmic timeline, formed from a swirling cloud of dust and gas. Planets, including our Earth, coalesced from this cosmic debris. Life, a miracle of complexity, arose on our planet, evolving and diversifying over billions of years. From the Big Bang's incandescent fury to the emergence of life on Earth, the universe has been on an epic journey of transformation. But what does the future hold for this grand cosmic tapestry? What ultimate fate awaits the universe we call home? Scientists peering into the depths of space propose theories about the universe's fate. Will it expand forever, or collapse back into a singularity? The Big Freeze suggests a slow fade into darkness. The Big Crunch envisions a fiery collapse. The Big Rip predicts a cataclysmic end. Each theory offers a unique glimpse into the cosmos's endgame. Where does humanity fit in these grand cosmic narratives? Imagine a universe where the stars themselves have long since exhausted their fuel. The once brilliant galaxies, now distant and faint, drift further apart in the ever-expanding void. Darkness reigns supreme, punctuated only by the faint glow of dying embers. This is the chilling prospect of the Big Freeze. In this scenario, the universe continues its outward expansion, driven by the mysterious force we call dark energy. As space stretches, its energy density decreases, leading to a gradual cooling effect. Temperatures plummet, approaching absolute zero, the point at which all molecular motion ceases. Stars, once beacons of light and warmth, will slowly fade away. Their nuclear furnaces, having consumed all available fuel, will sputter and die. The remnants of these stellar giants, white dwarfs, neutron stars, and black holes, will litter the cosmos like tombstones in a cosmic graveyard. Life, as we know it, depends on energy and warmth. In a universe gripped by the Big Freeze, life faces a bleak future. As temperatures plummet and energy sources dwindle, even the hardiest life forms would struggle to survive. The universe would become a desolate, frozen wasteland, devoid of the vibrancy and complexity that characterize it today. While the Big Freeze paints a picture of a slow, gradual demise, the Big Crunch presents a far more dramatic end to the universe. Imagine the cosmos, currently expanding outwards, suddenly reversing course. Gravity, that invisible hand shaping the universe, begins to pull everything back together. Initially, this cosmic contraction might go unnoticed, but over eons its effects would become undeniable. Galaxies, once drifting apart, would begin to draw closer. Their stately dances would devolve into a chaotic waltz of close encounters and collisions. As the universe shrinks, its temperature would begin to rise. The cosmic background radiation, a faint echo of the Big Bang, would intensify. Stars, squeezed closer and closer together, would experience runaway nuclear reactions, ending their lives in spectacular supernova explosions. Finally, in a grand finale of unimaginable scale, the universe would collapse in on itself. All matter and energy would be compressed into an infinitely dense singularity, a cosmic crucible where the laws of physics as we know them break down. This singularity, eerily similar to the one from which our universe was born, could potentially spark another Big Bang, giving rise to a new universe from the ashes of the old. Section 5. The Big Rip, when space and time themselves unravel. The Big Rip, the most violent and unsettling of the cosmological endgames, presents a universe not just ending but being torn asunder. Imagine a force so powerful that it overcomes the very fabric of existence, ripping apart galaxies, stars, planets, and even the building blocks of matter themselves. This cosmic unraveling is driven by the enigmatic force of dark energy. In the Big Rip scenario, dark energy doesn't just drive the universe's expansion, it drives an accelerating expansion. This means that the rate of expansion increases over time, eventually reaching a critical point where the very structure of space-time is ripped apart. the process would begin subtly. Galaxies would drift slightly further apart, their movement barely perceptible. But as dark energy intensifies, so too would the expansion. Galaxies would be torn from their clusters, their graceful spiral arms stretched and distorted by the overwhelming cosmic forces at play. Stars, once held together by gravity, would be ripped from their orbits, flung out into the expanding void like sparks from a dying fire. Planets would be torn from their stars, their once stable orbits dissolving into chaos. Eventually, even atoms themselves, the fundamental building blocks of matter, would be unable to withstand the relentless expansion. In the final moments of the Big Rip, the universe would dissolve into a chaotic sea of subatomic particles, each one infinitely far from every other. Space and time would cease to exist as we know them, leaving behind a void utterly devoid of structure or meaning. Section 6. Beyond the Veil, the Allure of the Multiverse. While the Big Freeze, Big Crunch and Big Rip offer compelling visions of our universe's ultimate fate, they are inherently limited. They focus on the observable universe, the portion of the cosmos we can detect from Earth. But what lies beyond the reach of our telescopes? What wonders and mysteries remain hidden from our view? The concept of the multiverse offers a tantalizing glimpse into a reality far grander than we could have ever imagined. It suggests that our universe, vast as it is just one of many universes, each with its own unique laws of physics, fundamental constants, and perhaps even its own forms of life. These universes, existing alongside our own, might be separated by unimaginable gulfs of space and time. They might be born from black holes, those cosmic abysses where gravity warps space-time to its breaking point. Or perhaps they emerge from quantum fluctuations, those tiny ripples in the fabric of reality that constantly create and destroy virtual particles. The multiverse, if it exists, represents a profound shift in our understanding of the cosmos. It suggests that our universe, with its billions of galaxies and trillions of stars, is just one small part of a much larger, more complex and ultimately unknowable reality. It's a concept that boggles the mind and ignites the imagination, offering endless possibilities for exploration and discovery. Section 7. Our Cosmic Legacy. What Fate Awaits Humanity. Faced with the overwhelming vastness of the cosmos and the potential for such cataclysmic endings, it's natural to feel a sense of insignificance. What does it matter what becomes of humanity, our hopes and dreams in the face of such grand cosmic events? Yet, we are a species capable of great things. We have explored the depths of the oceans, conquered the highest mountains, and even walked on the moon. We have built civilizations, created art, and sought to understand the universe around us. Our curiosity, our ingenuity, and our indomitable spirit have brought us this far. Even if our physical existence is ultimately extinguished, our legacy will live on. The knowledge we have gained, the art we have created, the love we have shared, these things will continue to exist, even if only as faint echoes in the fabric of the cosmos. And who knows? Perhaps we will find a way to survive the universe's ultimate fate. Perhaps we will develop technologies that allow us to escape to other universes, or to manipulate the very fabric of space-time. Or perhaps we will discover that the universe's end is not the end at all, but merely the beginning of a new chapter in the cosmic story. Section 8. Echoes of Wonder, Finding Meaning in the Cosmic Drama. The universe, in all its vastness and mystery, can be a humbling place. The sheer scale of the cosmos, the unimaginable distances, the timescales that dwarf human comprehension, these things can make us feel small, insignificant, even afraid. But the universe is also a source of endless wonder. The intricate dance of galaxies, the birth and death of stars, the emergence of life on our own planet, these are reminders of the beauty, complexity, and sheer improbability of our existence. As we contemplate the universe's ultimate fate, let us not despair. Let us instead embrace the mystery, the awe, and the wonder that the cosmos inspires. Let us continue to explore, to learn, and to marvel at the universe that is our home. For even if the universe itself is finite, our capacity for wonder, for curiosity, for a sense of awe and humility in the face of the unknown, these things are truly infinite, and it is in these qualities that we find our place in the grand cosmic drama, not as passive observers but as active participants, seeking to understand our place in the universe and to leave our own unique mark on the tapestry of existence.